Okay. Thanks a lot, folks, I guess. Uh, First of all, I would like to appreciate your patience. A lot of people were staying here for a long time. Thanks a lot. I'll try to do the justice for why you have stayed for a long time. So, what is a research assistant? Can someone tell me, like, have you seen research assistant in the practice? Have you used any? No? Anyone raise your hands if you have? Have you heard about Perplexity? Perplexity, how many? Oh, okay. Few people have. I think that's like one really good example of research assistants. It's basically like you want to do research about a specific thing, and you go to Perplexity and ask a question, and it does some stuff. It goes out, browses internet, and do some stuff, and then you get the answer, right? I think that's a good example of Perplexity. What I'm going to talk about is a research assistant that we have built. So all of this, the entire talk is based on a true story. And we are going to talk about the application of research assistants so that you are able to really relate. What I'm going to talk about is a story. So I think don't miss the beginning, and you will be able to kind of follow along quite well. So the application that I'm talking about is about drug discovery. Anyone know about drug discovery? What is drug discovery? Show of hands. What is it? Yeah, so I mean, to put in simple words, drug discovery is something like someone has a cancer and there is no medicine for cancer. So you want to invent medicine for cancer. And how do you do that? Is drug discovery. So if someone really wants to, I think this is like one of the most important, if you ask me, problem to solve in front of humans. And if AI is helping that solve, I think that is fantastic. So drug discovery is a process by which we invent new drugs. So any guesses on how much time it takes today to invent new drugs? Throw some number. 5, good. Any more? 2 years. 2 days. Oh my God. Oh my God. It takes 10 to 15 years, if not more, sometimes more than 15 years, just to get that one aspirin out. Can you imagine? So if, let's say there is a new disease that is coming out, it takes 15 years to have a drug that treats that disease. So there are a lot of experiments done, a lot of studies done on that particular compounds to actually make this happen. So the problem statement is divided into 3 parts. We'll talk about like why, what is the problem statement, we'll talk about like what solution we have built, and then we'll get into the how part. I think that's the most meatiest part for this talk. So this is a story. So about 4 years ago, a client reached out to us, and they had a problem that they wanted to kind of make most of their data. So they are into the business. This is one of the largest healthcare provider, and they wanted to actually, they are in the business for 50 years, a lot of time. And they have done a lot of studies. So as I said, right, like they have a lot of drugs. So they have, for 15 years, you're doing just studies for one drug. So you have a lot of studies, data available. And they wanted to make use of it, mostly. So to give you an understanding about how the drug discovery process looks like, and to understand that problem better, take a look at this funnel. So when we decided, okay, we want to investigate a particular disease and want to create a drug for a particular disease, scientists start with thousands of compounds, like about tens of thousands of compounds, and then they funnel it down to a few hundred compounds, and then they start testing on animals. You might have seen that in the movie. They start experimenting on rat, rabbit. Seen that? And then they find out that, yeah, I think out of those 100, 200 compounds, maybe these 4 or 5 compounds are most efficient. And they then start testing on humans. Because we really want to make sure that in that funnel, whatever testing happens on animal, actually they clear out most of the compounds so that like the testing, whenever it happens on humans, there are no that side effects. And then it goes down to actual FDA, and then it goes through a process. It takes like a lot of time, right? So we built a platform. We call it Prince. And the original ask from client was, we want to build Google for, this is 4 years old, right? So Google was not ChatGPT, was fun then. Google was fun then. So they wanted to build Google for all those past experiments so that they are able to kind of avoid duplicate efforts and save cost and lives. To give you a perspective, I think why this is a big deal, just 1 month study, if it is done on monkey, costs north of €1 million. Can you imagine that? Just 1 month, one study costs over €1 million. And you see, like for dog, for rat, it's a lot of money. It's not just about money, let me tell you. So in this same study, in the same course of time, about 10 to 12 monkeys are being sacrificed for that one study, right? If we have dog lovers here, over 10 to 12 dogs, or about 15 dogs are being sacrificed. It's slightly complex. It's like similar animals are used across multiple studies during the same parallel time, but still, there is a lot of impact on lives that we're talking about here. So the biggest problem is that if let's say an experiment was done by someone, if I find that experiment that was done, like say 10 years ago, I save all of it, right? I don't need to do that experiment. So if I'm able, so let's say tomorrow I decide that I want to do a study on rat, and I'm going to do this study for 4 weeks on this compound, and if I'm able to actually find this information, before even I start experiment, I'm actually saving all of this. And that's a good problem to solve, because this directly impacts in cost saving in animals' lives, and also it accelerates the time to market. So the problem that we're trying to solve here is how to find the right data at the right time. So it's a search problem, right? Everyone agree? So it's like, and then one way of doing that about 4 years ago was that we built a UI like this, where let's say we have a species field here, and I can say that I want to search for all the studies on a rat. I would just add rat here and then click search. And I get all the rat studies, right? Now, how do you build such a platform, right? How do you build such a search engine? So basically what you do is like standard, I think everyone would be aware. Like if I'm a scientist, I would have been doing experiments. So whenever I'm getting to a lab, I will just enter into my system around like, okay, this is a rat study, I'm going to do it for this much time and all of that. Now that system data is going to get captured into databases. So you have many such systems. And then what we do is basically we collect data from all those systems. That's called structured data, right? Your databases. So you collect all of that data, put them together, and give it a search form, right? So we might kind of maybe use Elasticsearch, OpenSearch, and things like that, and then make it available for search, and you have such a thing. So what you say is like our focus until that point in time was structured data. And about last year, what happened is we got a lot of power, I would say, through GenAI. The problem with structured data, if you want to know, like as I mentioned, right, the company I'm talking about is 50 years old. Now, there will be systems that were there for 50 years that do not exist today. And maybe today's system are like hardly 15, 20 years old at max. So we have a lot of data where the data is not captured in the systems. It is either sort of corrupted, maybe it is missing. So you have a structured data, but it's not complete. Whereas, how many of you from college here? I think everyone has gone to college. You do a project. At the end of project, what do you submit? What do you submit at the end of your project? Document, report, right? So we have all the reports available for the last 50 years. And now we have all of that data available to us that we could just explore and actually get value out of it. And that's a good problem to solve. Because now, earlier we wanted to kind of save time and money and cost for, and the data that we have available was limited. We have a lot of data available now. So we quickly realized that the problem that we have already solved is search problem. But why would someone come and search thing at the first place? because they want to answer a question, right? So if someone wants to answer a question, why don't we go and ask? Does that make sense? So if I am searching for a particular study, instead of me going and searching for a study, I would just have a particular question and I would ask. But, so what we did is like, for example, you have an ask use case. For example, ChatGPT, you go directly ask a question. Perplexity, you directly go and ask a question and you get answers, right? So that's great. So that's like a Q&A over, let's say, all the reports for 50 years or so. But if I want to go one step ahead, and I want to ask you, like, why do you ask a particular question, right? And if I ask someone, like, why would you go to ChatGPT, or why would you go to a Perplexity or any such system and ask a question? The answer to that is you want to do some stuff, right? You have a use case in your mind that you want to kind of follow. This is more of an agentic systems that we're talking about, that you now, instead of asking questions yourself, you tell it to do some stuff for you. And then that's the two phase. So here, for example, if I want to write complex reports, I mean, you could just ask it to write a report instead of me writing that report myself and asking questions for, okay, what do I write here, what do I write here? Make sense? Awesome, okay. So, most interesting part, how? Now, I want you to really pay very close attention to next 2 to 3 slides. That's your money slide. If you're done through it, you're all good. How many of you want to build, okay, how many of you are actually building LLM applications here? Nice. How many of you want to build LLM applications here? Awesome. Okay. This is one slide you want to know, because 90% of the times when you're building applications, you're going to know what is RAG, right? So let's say you ask a question to language model. LLM is large language model. Clear? You ask a question to LLM, you get an answer. So if you ask a question which is, what's the meaning of life in 10 words, you get a really good answer. I think I really like that answer. Kind of resonates with me on what I think about it. But if I ask a question, which is, what animal was used in a particular study? Now that's, let's say, considering that ID is a fake ID, but considering that ID is a real ID, it says, I don't know. I mean, that this model is being very nice. That says, I don't know, it might also produce some sort of answers here. It wouldn't really mind giving some answers. But the point is, this data is not the model is something trained on, right? So if I want to still answer that question, one option I have is I can give some context. So for example, if you see I'm looking at this particular study, and I see that the first line here actually corresponds to mice. So it gives the answer, mice, right? This is stupid. Like, what is big deal in this, right? Like, so what RAG is really? So imagine that. Oh, sorry. Imagine that you have this question. So instead of asking this question to LLM, what you would do is you have some magical system that you ask this question to that system. And the job of that system is to populate that context dynamically. So what you see on the top, imagine that that is being populated dynamically. So let's say if you have a book that you're reading, or if you're from college, you're studying something, you ask a question, it'll actually go to the book, it'll figure out what page number, what section, what paragraph this answer might be from. It'll give you that paragraph on plate. And what you do is you take that question, take that context, and give it to language model. And you get the answer. This is all what RAG is, okay? This is all you need to know. The system that we're talking about here, it's not a new system. It's called information retrieval. It's been around for a decade. So it's like something not invented in the last 1 year or so. So a lot of research is available on that. And this thing is powered by semantic search. How many folks know semantic search? So you search for gelato, you get ice cream. You search for football, you get results for soccer, right? That's what keyword search. That's basically the search by meaning. Right? So whatever that is meaningfully similar, you'll get that. So if I'm asking a question, and from the meaning of that question, it corresponds to a particular paragraph into the book, whatever, in that previous example, it will pull that out, right? That's semantic search. Conceptually, this is cool. This does not always work. It works with smaller amount of data, right? So the system, the production system I'm talking about has, I don't know, we have over 2 million chunks, over 2 million paragraphs, so to say. We have over 20,000 reports. And just a trivia, like one report, when I'm talking about, one report is about 800 to 2,000 pages. And we have over 20,000 such reports that we need to actually build system on. So semantic search itself, I mean, if you ask the same question, you'll get so many paragraphs from millions of data, right? So you need to do something more. And that something more is called pre-retrieval and post-retrieval. And we'll talk about it in a bit. So we have a pre-retrieval, then we have post-retrieval, retrieval, and then we have post-retrieval. Awesome. Okay. So if you have followed all of this, that's RAG. So you can go and start building your system. That's all you need. Now, what I'm going to talk about is slightly advanced concept, which is advanced RAG, and I'm pretty sure you'll be able to follow. That's kind of our Q&A architecture, and on the right-hand side, what you see is the tech stack that we have used. I will explain to you all of this, so don't worry. So basically, what happens is, first of all, you have a lot of reports. What you do is you convert those reports, take them into chunks, extract paragraphs out of individual PDFs, and then feed them to a database. So you have all the study reports stored in database, right? Now what you do is you want to actually, when user asks a question, you want to actually pull the right thing out of this database so that you should be able to present it to LLM. How does that work? So you ask a question. So let's say this question is, one of the findings, like what in a particular study, like were any of these findings present? And then maybe you don't know what those findings are, like piloerection, ataxia, loose feces, eyes partially closed. And like, these are the findings, let's say, user wants to find out. So what we do is, first thing, we have millions of chunks in the database. What I want to do is, I want to, first of all, narrow down. I can't work with all of that. So obviously, one thing I want to do is I want to shortlist. I want to kind of narrow down the space of vector space, narrow down the vector space. So what I would do is I would go and ask a language model that, hey, language model, look at this question, extract all the filters possible. And one of the filter here, looking at the question, we see that, there is a study ID. I can bring that out. So it creates a filter condition saying that there is a study ID, and then this is study ID. I can have more such filters based on what database I have, right? And magically, now I had millions of vectors. What happens is I have now 50 vectors, maybe more, maybe 100, maybe 10, depending upon the filter condition, right? So now my semantic search is becoming very powerful. I can be confident that it will work. But semantic search is also like something like the other problem that usually happens is we are humans who are going to ask these questions. Are we good at prompting? I don't think so. So not yet, at least. And I don't think we should be. I think the system should be able to kind of really understand what is the intent, which is a very interesting problem to solve. But what we do is, if you ask the same question slightly differently, you might get slightly different results. To overcome that, what we do is, we would then take that question and ask the language model, can you create more of such questions? So for example, now it looks at, for example, loose feces, for example. And it says that, I will create the slightly modified question that has exact same meaning. And it says, this is like diarrhea. Same thing. Watery stool, same thing, right? So it creates multiple versions of the same question. And now we take these questions. I didn't talk about keywords. I think all of us are doing keyword search for long. I think keywords, I think if you are building such things, one free thing you get is this keyword search. It's like really BM25, TF, IDF, these algorithms are there for like over 50 years. I don't know, maybe more aged than anyone in this room. And then they are like the best algorithms, most performant, most cheapest. You should always do that. So along with semantic search, we also shove in the keyword search, and then we apply the filter. And we do varied hybrid search. And now you get some results. So let's say we got some about 20 chunks. Now we can say that out of those millions, we have these 20 chunks, where there is the most probable answer present. But current LLMs are also like, if you might have heard about needle in the haystack test, etc. It's not always possible that you have all of these kind of chunks available and then you could actually get answer from. So what we do is we give all of this to something called as cross-encoder. And cross-encoder brings only 7 chunks out of it. Cross-encoder is something that you look at a question, look at a chunk and say, is that a match? If yes, it gives a score. And then you bring in top things that you feel are most relevant, and then you give it to the LLM and you get the answer. So, and then you get the answer. So this is like one slide. If you want to take out from this entire presentation, you should really take this. So this works great. So for example, when we were asked our users to try this system out, they asked some various questions around like fluorosis, around like, give me a one type of toxicity, except other type of toxicity. This was not possible earlier to find answers to such questions. So for example, for the question with fluorosis, our users were like, oh, I think we don't have that data. And someone said, okay, let me just try it. And then someone said, okay, find compounds associated with fluorosis. And they got results, which is quite cool, right? And then it went ahead and actually also proposed a particular study design, and then it has access to those type of reports, so it's able to kind of also infer and give you some new study designs, which was quite cool. But this is not the best. The limitations in the previous architecture is that you have hardly, basically, all the answer that you could generate is based on only 7 chunks. And here what you have is more data, right? So I think let's say if you ask a simple question, this works quite well. But if you ask a complex question, let's say to answer this complex question, there is a lot of, you need, let's say 20 chunks to answer this question. It's not possible. So you can't answer. So what do? I would ask, like, what would you do, right, if you are given a complex question? So usually, as a human being, the first thing you would do is you will take that question, break it down into smaller questions, right? That's what you want to do. Now, let's say if I'm the person, what I would do is I'll take the simple question, and then I will look at that individual question, and then go and make database query, maybe look at the report myself individually, and try to answer individual questions, and then combine all of that together, and then I have a final answer. That's what you would do. But I would also do one more thing, and I'll look at that answer, I'll go back, and then see, oh, is this question, is this answer, is it complete? There is something missing. If there is something missing, I would go back, repeat, right? So what we would do is, like, for example, if you look at that diagram, the Q&A architecture is actually able to solve those simple questions. What you want is, you have a complex problem to solve, so you need someone to kind of break that down, and you need someone to actually combine and repeat until you have the full answer available, the complete answer available. And that is something known as agent. Heard about it, agent, before? Yeah, okay. Be aware about this guy. Maybe this guy will take your job one day. I'm just kidding, it won't. But yeah, I think, so if I would like to explain this thing again, right? Now this agent is sort of a personified version. So it takes this agent, it looks at this Q&A architecture. So it's like, for example, I'm talking to you via mic. I'm using mic as a tool. So this agent is using this Q&A architecture to answer a question. So it's using that as a tool. So we call it RAG tool. RAG, everyone aware? Retrieval-Augmented Generation. So whatever we have built so far in that previous section just becomes one tool. And you could have many such tools. You could have like a database tool, for example. You could go ahead and you have, let's say, internet tool. So you can actually, today you can go on ChatGPT and ask a question that, okay, what is news today? You get the answer. It goes, looks at the internet, does the RAG on whatever it finds, and then gets the answer, right? That's how it works. So this particular thing, this capability now enhances and adds a lot of use cases to your plate. Now you can do a lot of complex things hassle-free. One such thing that you could do is, we call it writing assistant. Now, what is writing assistant? For example, now, if I'm a scientist, what I need to do is I need to actually go write a report, and then those report could be like maybe 50 to 100 page long. And to write that report, I need to actually look at 10 to 15 study reports, which are 1,000 pages long. So imagine that I'm a scientist. My job should be to focus on science. What I'm doing is I'm looking at those reports, trying to copy-paste things from here and there and write another report based on all of that. Why not we give it to this, right? So our scientist basically wants to write such reports. So let's say, so what it could do is it could come and say, okay, I want to write an IND. You remember that search, ask, do? We solved the ask. This is do. So now, user would come and say, okay, write an IND report. And this IND report is basically, it's maybe 100, 200 pages long. And now what we have is basically, we have a researcher. What we built was a researcher, right? It has access, it can do research on its own. We could also add another agent, which is like writer. Now, writer knows exactly what the IND report means. It knows what section should go into what report. It knows what information should be there. It knows exactly how the table structure should be. So that's agent now specializes into like specific writing stuff. And you have a reviewer, right? So you have a question. So basically, you need to somehow identify and verify if whatever writer is spitting out, it is true or not. And that's a multi-agentic system. And this is something really, really, really cool that we are building. It is like extreme, okay, it is really complex to build. I mean, like it is very easy to build for a POC. It is very complex to productionize it. And I think you would go nuts if you are actually trying to productionize it. So you need to break your head quite a lot on this. But to give you a perspective about this on impact, on impact, so earlier, when we had this system not in place, it used to take days to answer simple questions. It used to take, I don't know, maybe days to weeks to answer complex questions. Months to write reports. Months. I think we're yet to solve this problem. We are actually working on solving this problem. And also, like, visualizing is now seconds, which is quite cool, right? So this is not all free. You can build POC in one day. You can't productionize it. It is really tricky because there's a lot of hallucinations, a lot of things you need to take care of. And it is non-deterministic system, so you ask a question, it will always give you a different answer. How do you trust that system, right? First of all, I would like, so one challenge which I wanted to kind of call out is that first, if you want to build trust, we wanted to build trust with the developer team. Like the developer team should trust what is going on and should have understanding about what the heck is going on behind the scene. So because what you're doing is you're asking a question, that question is going to LLM, then the output is going to LLM, then again output is going to LLM. So it's like, it's very easy to kind of go in a different direction. So you need to have really good understanding about how these systems are interacting, how these LLM chains are actually working. So that's observability. You need to also have good, in the interest of time, I'll just move on. The second thing, and the most important thing, is explainability. So the complex workflows you build with agents, right? So you're making hundreds of agent LLM calls. Your user persona, for example, in our case, is a scientist. Scientists are like, they have a different, specific way of working. How do you make sure that those scientists trust these answers, right? So you should be having some sort of explainability around like, after asking questions, we did exactly these things, and that's how we come up with the answer. That explainability should be there. And unless you don't have it, it's hard to actually trust. I mean, at least I would not trust any system that would just give me answer out of the blue. I would not know if that is really correct or not. So you need to kind of have that explainability and really need to think about how you do it. I think UX is also something that is evolving in this space, and that is will be something next to really watch out for. Then the citations is extremely important. We are talking about compliance critical reports. So if anything that is given wrong as an answer, if that wrong answer is incorporated, we're talking about lives. So you need to be very careful that every question, every answer, every sentence of your answer is actually cited properly. And when I say cited properly, what I mean is, what we do is, for example, every answer has a reference to, we just don't tell them that, okay, what is the report it is built on top of. We tell them exactly what page number, what section, what paragraph, what line of that report was actually used to come up and write this answer. I think if you are bringing such transparency into the system, I think that becomes easier for users to also adopt. And then writing like the right cognitive architecture. So I think someone mentioned like you have agentic systems where like you ask a question, you get answer. And there is like if I want to put it on the axis, right, there are two types of systems available. Like one system where you have like, you give it a thing, ask it to go crazy, get back an answer. That's like super complete automation. One system where you need to have a complete controls, you need to actually tell exactly every step. We don't want both of them. We want to actually find the right balance, the sweet spot where you have the right control and the right automation. So you need to really think about, okay, how you kind of bring that in and how would a human think. So I think you need to have like a right cognitive architecture. You need to kind of bring in human in some complex agentic workflows as needed. I can't talk enough about evaluations. So your normal testing do not work for such workflows. So when you're talking about evaluation, have you heard about evals before? Evals is like a also growing field. I think something that if you are building and if you plan to build, start with evals. I don't have enough time to actually talk about it, but start with evals. And yeah, so I need to have like right system controls and like security is must. I mean, many examples. I can talk about many examples where these systems are like for example, exploited for bad. So you need to have like right security and guardrails in place. And all of this is not sufficient, so you need to have like kind of, this is not an exhaustive list, you kind of keep on improving on this. Thank you. That's my QR code for LinkedIn. I think I couldn't cover everything. If you want to stay in touch, you can maybe scan it and then we can stay in touch.
Thank you so much, sir.
I'm open for questions if I can.
Yeah, of course, sir.
Yeah.
Does anybody have any questions?
This one?
Yeah, this one. So just thinking out loud, how would you compare this to a GAN network, where a network generates some data, then it tries to falsify that data and learn from it, right? Generative adversarial network.
Mm-hmm.
So the second part where the writer writes, reviewer reviews, researchers then finalize that data, right? How much similar do you think it is to a GAN network?
So I'm not an expert on GANs, to be honest. What I can tell you here is, here we are talking about simple agents that you would build on top of LLMs. So we're not going deep down into ML at all. So this is like completely on top of LLMs. So I think it's completely different.
Okay, thank you.
Yeah. Thank you. Okay, I got some time I actually lost. So evals. I think if I click on a button, I know that I'm going to have this action. That's a test. Now, this does not work with LLM because you ask a question, it's always going to give you a different answer. Now, how do you understand that this is actually working, right? Because now you can't have like a true or false. You need to have like a range of answers now. You can actually, so for example, I can say that one good example of evals, maybe I'll only give one example, is hallucination, for example. Now, how do I know if my answers are hallucinating, right? How do I know that there is something that is really going wrong with my answer? What I could do is, I can, and these evals I'm going to talk about is LLM-based evals. So I think for test also, for evals also, you will need LLM. You need to trust someone. So what I would do is, I will take a question, I will take the answer that is got. Now, what I can do is, along with that answer, I can also look at this answer was based on like these 7 chunks, you remember? So I will also get those context. And now I look at question, I'll look at answer, and I'll ask LLM that, okay, look at the question, look at the answer, look at the context, and draw out facts from the answer. Is this answer completely based on facts? And give us a score. And you can ask it to give it a score. You could also do more statistical things, for example, that okay, you can ask it, okay, that look at the answer, extract facts from the answer, look at the context, extract facts from the answer, do a match, and then come up with a score. So I think there are different things you could do. But it's more like, now you're not talking about true or false, you're talking about a range of between 0 to 1 as the answer. And interestingly, maybe 0.8 is great for you, right? Your goal should be, okay, how do I move the needle? How do I go from 0.8 to 0.85? How do I go from 0.85 to 0.89? That's the goal. That's how you improve.
How to implement security part using guardrail?
Good question. So I think in terms of guardrails, like specifically when you're talking, so there are a bunch of guardrails out there. For example, NVIDIA has a great one, like NEMO guardrails. I think you should really, if you are interested, look out. Basically, what you're looking is, if there is a harmful content, if there is a harmful question that's coming your way, you should be able to stop it right there. You should be able to kind of not give that answer. If there is something else that is happening, for example, if someone is trying to do prompt injection or some specific attacks, you should have some sort of system in place at real time to actually stop that those things from happening. So I think that is also evolving field. And you could also do this, for example, so you need to be very, very, very careful if you are building a public-facing such application. Anything could go wrong because you are giving it a text box in plate, asking it to write whatever you want, and then expect right answers. So you need to have like really good systems in place that would kind of detect what is right, what is wrong, and then kind of throw away the nasty things. So, but if you want like a how to do it, Nemo guardrails, maybe just check that out as an example. Awesome. Okay, all right. Thanks a lot.
Thank you so much. Please give